Hi everyone, welcome back to the online tutor once again. So last tutorial we have discussed about the quadratic function basic things. So now I am going to discuss some past paper questions related to uh, the last video theory part. So you can see now in the board fx equal p squared x squared plus 2x plus 1 equals 0. So here the p was given, the range is greater than 0 and less than equal 1. X squared show that fx has real roots. So we have to show this function has a real root. So what can we do now? Uh, in our theoretical base about the real roots, the discriminant is always should be greater than or equal, right? So I'm going to check the discriminant of the function fx. The discriminant is b squared minus 4ac. So here b is 2, a is b squared, c equal 1. So when you substitute it, 4 minus 4 into a is b squared and c equal p. C is not 1, C is p. 4 out, 1 minus p cube. So 1 minus p cube can be written with the factors 4 times 1 minus p into 1 plus p square. So p is in between 0 and 1, can be equal to 1. So this part can be greater than or equal 0. So other bracket is 1 plus p square is greater than 0. Therefore, the discriminant is greater than or equal 0. Therefore, fx has only real roots. So this is the way of proving the function has a real roots. So this question was taken from the 2019 LA paper. Okay, this is another, I think I don't remember the exam year, but 3x squared minus 2a plus bx plus ab. Show that fx has a real roots. So once again you have to check the discriminant. Check the discriminant. So this is equal to ax plus squared plus bx plus c. A is 3, b is minus 2 times a plus b, c equal ab. So this is 2 minus 2 times a plus b minus 4ac. 4a plus b square 12ab. So you can expand now, it's 4a squared b squared 2ab. When you expand the bracket, 8ab plus 4b squared minus 12ab. Okay, then it's minus 4ab plus 4b squared. 4 can be taken out, a squared minus ab plus b squared. So we have to show this discriminant is greater than or equal 0. So here so I think we have to use the computing square method to make like whole thing is square plus b squared minus b squared over 4. I use the computing square method. I think you all of are okay with that. It's in our grade 11 now. Okay, now it's 4 times a minus b over 2 whole thing is square plus 3b squared over 4. Okay, now you can see here they have given ab's real numbers So the first bracket, it's greater than or equal 0. 3b squared of also greater than or equal 0. Therefore, the discriminant greater than 0, fx has real roots. Right. So finally, it's become a real roots. Discriminant is greater than or equal 0. Right. So this is my next example. 4x squared minus 16x plus 4k. If the roots are of the fx are real, find the range of k. Once again, check the discriminant. A equal k, b equal minus 16, c equal 4k. Discriminant greater than 0 to be real, greater than or equal 0. Right. This is what I got. So according to the inequality lesson, you have to check the sign of the discriminant. It's minus 4 and plus 4 in between. Substitute the values. If you put more than 4, it's negative. In between minus 4 and plus 4, it's positive and negative. To be greater than 0, the k should be in between minus 4 and plus 4. Greater than or equal, sorry. This is the range of k. Okay, this is my next example. If the roots of gx are real, find the value of k. First thing is I made it like ax squared plus bx plus c equals 0 format. So now we can check the discriminant. No? Check the discriminant. This is ABC. A equal 11 plus k. B equal minus k minus 3. Z equal 1. I substitute to the b squared minus 4ac. So this can be factorized. Ne? Plus 7 and minus 5. So I draw the k-axis. Minus 7 plus 5. So I got positive, negative, positive. When I put more than 5, it's positive. In between minus 7 plus 5 like 0, it's negative, and less than minus 7 positive. Therefore, the k should be in between more than 5 and less than -7. Okay, this is what I got for that example. So now I think you have a good idea about the discriminant. So the discriminant is directly uh, gives you the idea about the behavior of the roots, right? So roots can be real, root can be coincident and real, and root can be non-real. So these can be happen. So all depend on the discriminant value, right? Okay, now I'm going to discuss the another theoretical part in this quadratic function lesson, relation between roots and the coefficient of the quadratic equation, right? So the previous chapter we have discussed about the quadratic functions, right? So the quadratic functions, uh, we using the computing square method, we found the quadratic functions, the roots, right? So if you want the roots, you should equal to the quadratic function to the 0, and the root should be fine, right? So however we got the roots of the quadratic functions. So now I'm going to continue this part, right? Quadratic equation, relation between the roots, right, and the coefficients, right? So ax squared plus bx plus c equals 0 is my quadratic equation, and I assume which has two roots, alpha and beta, as the real roots. And according to our main equation, this is our equation of the roots, and separately I'm going to equal this root for alpha and beta. So when I equal x as alpha, these are roots, and x as alpha, x as beta, and I'm going to uh, add these two to cancel the square root part. Equation number 1, equation number 2. When I add these two, you can see the square roots getting cancelled. Alpha plus beta left hand side. Right hand side, we will have minus 2b over 2a. It's minus b over a. This is the first relation, right? The addition of the roots is equal to minus b over a. Minus b mean the x coefficient, a mean the x squared coefficient. Similarly, I'm going to multiply these two roots, alpha and beta, because you can see this is like the difference between two square roots, right? Minus b plus b squared square root. So this is difference between two square solution. B squared is getting cancelled. 4ac over 4a squared. 4 cancel, a cancel, c over a. So that means the product of the roots is equal to the z over a. C mean the constant, a mean the x squared coefficient. Okay, let's summarize it. X squared plus bx plus equals 0, which has roots alpha and beta. So I'm going to divide this all by a, then it's like x squared plus b over ax plus c over a equals 0. So can you remember the previous result? We had addition of the roots ABC are real. Addition of the root is alpha plus beta, it's minus b over a, and the product of the root equation is z over a. So that means the product is given by the z over a, addition is given by the minus into b over a. So this is the summary, right? So always you should understand, if you have 2x squared minus 3x plus 5 and those roots are assume alpha beta, then addition of the root is equal to minus b over 8 3 or minus 3 over 2. Minus means plus. The product is 5 over 2 constant divided by x squared coefficient. 5 over 2 and 3 over 2. So we can directly connect these coefficient with the roots. Right. So now assume if alpha beta are the roots of the quadratic equation x squared plus px plus q equals 0. Find the equation whose roots are alpha squared and beta squared. First of all, I'm just write the addition of the root, it's alpha plus beta, it's minus p. Product of the root is alpha beta equal q, using our previous identification. And we need the equation whose roots are alpha squared and beta squared. You know, all the time the x coefficient is addition of the roots. The constant is the product of the roots. Because can you remember, it's minus b over a, addition of the roots. C over a mean the product of the roots. So then you can write it like alpha squared beta squared x plus alpha squared beta squared equals 0. So we have to find this alpha squared and beta squared using our alpha beta addition and alpha beta product. Alpha squared beta squared is equal to alpha plus beta whole thing square minus 2 alpha beta. So when you expand it, it's cancelling. So alpha plus beta mean minus p whole thing square. It's p square. Alpha beta mean q. It's 2q. Alpha squared beta squared product is q square. So now you can substitute it to the main equation. X squared minus addition of the roots is p squared minus 2q. Product of the root is q square. This is what I got. Okay, next example. Find the equation whose roots are alpha cubed and beta cubed. So how to get the alpha cube and beta cube equation roots, equation in terms of p and q. Okay, again I have to write the addition of the roots and the product of the root like into the main formula. This is the main formula. You have to work with the alpha cube and beta cube. Alpha cube plus beta cube, it's like alpha plus beta whole thing cube minus 3 alpha squared beta 3 alpha beta square. I deduce the middle terms of the alpha plus beta whole thing cube. Alpha plus beta is minus p as previous, and alpha beta is q. This is 3 alpha beta out, alpha squared plus beta squared. Sorry, this is not alpha squared plus beta squared. It's 3 minus 3 alpha beta. No? When you pull alpha beta, it's not alpha squared beta squared. It's alpha beta. Okay, this is what I got as a quadratic function whose roots are alpha cube and beta cube. So addition of the root is 3p cube minus p cube into x, and the product of the root is q cube. Right. Let's move to the next sum. Relation alpha beta are the roots of the quadratic equation. This the previous one. Find the whose roots are alpha to the power 4 and beta to the power 4. Again, you have to find the product and the addition of the roots separately. This is my alpha plus beta. It's minus p, alpha beta is q. The addition of the root is alpha 4 plus beta 4x. Product of the root is alpha 4 beta 4. To get alpha 4 plus beta 4, I'm going to use the Pascal triangle expansion. The middle terms it 1 1 1 2 1 1 3 3 1 1 4 6 4 1. The middle terms are 4 6 4 minus 4 alpha cube beta minus 6 alpha squared beta squared and minus 4 alpha cube beta cube. This is alpha plus. You can pull 4 minus 4 alpha beta and it's alpha squared plus beta squared inside the bracket. 6 alpha beta whole thing is square. This is it's minus p whole thing to the power 4. This is alpha beta and alpha square beta square mean alpha plus beta whole thing is square minus 2 alpha beta. Okay, now you can substitute from the p and q. This is minus p fourth power. This is minus 4q 4 alpha beta minus 4q alpha plus beta square mean p square 2q minus 6q square. When you expand it, you will get this result. The product of the roots is q to the power 4, right? Okay, now you can put this all to the main function. This is the equation whose roots are alpha to the power 4 and beta to the power 4. Right, children. So this is the end of the today tutorial, and I think you might get some idea about the quadratic equations. So we today discuss the behaviors of the roots, right, using the discriminant, and also we discuss the relation between the coefficients and the roots of the quadratic equations. So right, so this the end of this tutorial. So next tutorial I am going to discuss more examples using that theory part. And thank you very much for participating. And if you didn't subscribe my channel, don't forget to subscribe and share these videos with your friends. And thank you very much. Have a nice day. Bye bye.